This is Mrs. Ridgway, and I'm going to continue Excel Chapter 3 module. I'm on page 28, and I'm looking at page 28 and 29. Be sure to study, kind of look at this page. It tells you that a mixed cell reference is a cell reference that has both absolute and relative components in the reference. For example, B with a $8 is a mixed cell reference, and it's considered mixed because there is no $sign to the left of B. If there were a $sign to the left of B, then it would be an absolute reference. An absolute cell reference is a cell reference that does not change when the formula containing that reference is moved to a new location. Absolute references have the $sign symbol before the row and column components. For example, $B, $5 is an absolute cell reference. And when you copy your formula across or down, it will remain B5 because the $signs, I want you to think of those as anchoring. You're anchoring down to the cell B5. It never changes. A relative cell reference is what we've been working with thus far. A relative cell reference is a cell reference that changes when the formula containing that reference is moved to a new location. For example, B11 and B6 are both relative cell references. We're going to be looking at VLOOKUP function. The VLOOKUP function returns values from a vertical lookup table by specifying the value to be matched, the location of the lookup table, and the column containing the return values. We're going to learn more about VLOOKUP. We are also going to be looking at the if function, which is a logical function that tests a condition, and then it returns one value if the condition is true, and another value if the condition is false. On page 29, okay, it's pointing to a vertical lookup table. This is used to retrieve the data based on the matching the category values found in the first column of the table. Down below, you'll see the notes. The entries in the first column of the vertical lookup table are used for matching to a lookup value specified in the VLOOKUP function. Values in the other columns of the vertical lookup table are returned from the matching row found with the VLOOKUP function. Now, I know that was probably Greek to you and went over your head, but we will be working with the VLOOKUP and you'll get a better understanding. Let's begin first of all on page 30, calculating running totals with the quick analysis tool. The quick analysis tool appears whenever you select a range of cells, providing easy access to the most common tools for data analysis or chart creation or data formatting. We're going to create a running total using the quick analysis tool. We have on the screen, we have our workbook. We are clicked on the call center log worksheet. We're going to select the range J5 through J515. J5 select it all the way down to 515. Now you can scroll down or you can use the name box and type in J5 through J515 and it will highlight it for you. All right, so this column contains the duration of each call made to the call center. We're going to click the quick analysis button, which is right down below to the right. This is the quick analysis button, lower right corner of the selected range. And we're going to display the options available with the Quick Analysis tool. So I'm going to click it, and these are the options. In the Quick Analysis tool categories, we're going to choose totals. The Quick Analysis tools that calculate summary statistics for the selected range will appear. Now we're going to click the right arrow to view additional Quick Analysis tools. Click the Running tool. The Running tool of call durations is added to the adjacent range K5 through K515. Scroll up the worksheet and select cell K5. See figure 322 on page 31. So it automatically entered the running total of call minutes created by our Quick Analysis tool. Column K now shows the running total of call durations in minutes. Now, by default, Quick Analysis summary statistics are displayed in bold. You'll remove the bold formatting so that the values in column K have the same formatting as column J. To remove the bold formatting from the running total, we're going to select the range K5 through K515. So I'm going to click on Home to show you how to do the name box. Click in the name box, type K5 through K515, and then press Enter and see how it selects the entire column. On the ribbon, we're going to click the bold so that it will remove the bold formatting from the selected text. Now click cell K5, or just click anywhere in the worksheet to deselect. To create the running totals in column K, the Quick Analysis tool first adds the formula, the formula equals sum, and then it puts in parentheses dollar symbol J, dollar symbol 5 through J5, and it closes the parenthesis. When that formula is extended down the column, the formula changes in cell K6 to read equals sum, the dollar J, dollar 5, because this is absolute, it anchored it to J5 through J6. Okay, J5 was not an absolute, so it changes to J6. And the formula changes in cell K7 to equal sum, parenthesis, dollar sign J, dollar sign 5, which is absolute, through J7, which is always changing. As the formula is extended through the range K5 through K515, the sum function covers a longer and longer range of cells. Okay, now on page 32, we're going to be exploring cell references. Excel has 3 types of cell references: relative, absolute, and mixed. Each type of cell reference is affected differently when a formula or a function is copied and pasted to a new location. We have been working with relative cell references up to this point. Excel interprets a relative cell reference relative to the position of the cell containing the formula. For example, if cell A1 contains the formula equal B1 plus B2, Excel interprets that formula as add the value of the cell 1 column to the right, which is B1, to the value of the cell 1 column to the right, and 1 row down, which is B2. So we're going to continue to work with, there's a perfect example of relative references. Look at figure 3-23 and study that for a few minutes. The bottom of page 32, absolute cell references. An absolute cell reference remains fixed. even when a formula or function is copied to a new location. Absolute references include the dollar sign before each column and row designation. For example, B8 is a relative reference to cell B8, while $B $8 is an absolute reference to that same cell. Figure 3-24 shows how copying the formula with an absolute reference results in the same cell reference being pasted in different cells regardless of their position compared to the location of the original copied cell. Okay, so relative, it changed to A3, A4, B3, B4 as you copied it down, whereas when it's absolute, then it's going to be A3, A3, A3. It does not change to A4. Mixed cell references on page 33. A mixed cell reference contains both relative and absolute components. For example, a mixed cell reference for cell A2 can be either $A, which holds down the column A. So it could be a $A2, where the column is the absolute component and the row is the relative component. The relative component continually changes. Or it can be entered as $2 with a relative column component and a fixed row component. A mixed cell reference locks only one part of the cell reference. When copied to a new location, the absolute portion of the cell reference remains fixed, but the relative portion will shift. And there is an example of formulas using mixed references. Take a moment to study figure 3-25. You will use relative and absolute references when you enter a formula in the call center log worksheet. We're going to be entering an absolute cell reference. Kiara's goal for the call center is to have every call answered within 15 seconds. To analyze how well the call center is meeting this goal, we will determine by how much each call meets or exceeds the 15-second goal. To calculate the difference between the hold times and the 15-second goal, we're going to click in B28. B28. Enter the number 15 as your hold time goal. Scroll up the worksheet and click in cell L5. Enter the formula equal H5 minus absolute B absolute 28. And this is going to, we enter the formula to subtract 15 seconds from the hold time. And we're going to press enter. The cell displays a -10, indicating that the customer was on hold for 10 seconds less than the 15-second goal. Now we're going to drag the fill handle over the range L5 through L515 to extend this formula through the rest of your call log. So I'm going to click and I'm going to double click so it will fill. And again, the banded row is missing, so we need to click on the autofill options and choose to fill without formatting. Our banded rows have returned. Number 5, we're going to scroll up the worksheet and we're going to click L5 to deselect the range. L5, deselect the range. Now look at figure 3-26. Make sure your numbers are the same. Because the formula uses an absolute reference to cell B28, it will always point to cell B28, even as it's extended through the range, L5 through L515. That's the formula in cell L6 is equal H6 minus absolute B, absolute 28, as you see up here in the formula bar. The formula, I'm going to click L7, and it shows equal to H, well, I'm in set 6 instead of 7, so it's equal to H6 minus absolute B, absolute 28. All right, now I'm going to click in L7, and L7 is equal to H7 minus absolute B, absolute 28, and so forth. So it doesn't change if it has the dollar symbol. That's an absolute reference. Okay, you can easily cycle between relative absolute and mixed cell references in formulas by selecting the cell reference in the formula and then pressing F4 while in edit mode. Okay, so I'm going to go up here so that I can show you. I'm going to double click the B, the absolute B, absolute 28, and then I am going to press the F4, function 4 key. I'm going to press it one time, and now you can see that we have the absolute row. This is a mixed reference. I'm going to press F4 again. Now we have an absolute column, B, but 28 is relative. I'm going to press F4. We have relative, B28, relative. And then I'm going to press F4 again, and we're back to our absolute B, absolute 28. So if you type the formula equal A4, and then you were to press F4, the formula changes to absolute A, absolute 4. And then if you press it again, it changes it to anchoring down the row. You press the F4 a third time, and it's going to anchor down the column. So the row only, and then the column only, and then you press it the fourth time, and it returns to a relative, just a simple equals A4. Okay, that's for example. It cycles through the different functions there. Relative functions through the different functions of relative, absolute, mixed, and mixed. Mixed with row, mixed with column. All right, working with the if logical function at the bottom of page 35. A logical function is a function that returns one of two possible values depending on whether a given condition is true or if it's false. The condition is entered as an expression, and then you use conditional expressions in logical functions like the if function. Well, the condition is entered in an expression such as A5 equals 3. Now, if cell A5 is equal to 3, then the condition is true. If cell A5 is not equal to 3, then the condition is false. Page 36, where the logical test, that's the logical test, is a condition that is either true or false. The value, if true, is the value that will return in your, it'll be placed in your worksheet. If it's false, then the optional argument value will be put into your paper. And there's an excellent example on page 36. So it's equal if, parenthesis, if A1 is equal to B1, comma, if it is, then put the value 100, comma, if not, then put the value 50. All right, let's look at another example. If A1 equals B1, comma, then put whatever is in C1, comma, if it's true. If it's not true, then put whatever is in D1. So it will enter whatever value is in C1 or D1. The equal symbol in if function is a comparison operator, which is an operator expressing the relationship between two values. Look at figure 3-27 at the logical comparison operators. We have the equal, we can use the greater than, less than, the greater than or equal, the less than or equal, or if you have the arrow, both arrows, then this is telling us that it is not equal to the value. If the value in cell A1 is not equal to the value in cell B1. Okay, so thus, let's look at what we have. Here's another example. If A1 is less than or equal to B1, okay, if this is true, then they want, notice the quotation marks. You've got to put quotation marks if you're putting in some information, some text. So if it's true, then insert the words goal met. Otherwise, if it's false, then enter the words goal failed. Okay, so Kiera wants a quick way to tell whether a customer was on hold longer than 15 seconds. So we're going to use the if function to indicate if a sale exceeds the hold time goal. Click cell M5. Oop, I've got to escape. There we go. Now, M5. On the ribbon, click the Formulas tab. And then in our function library, we're going to be using logic. So we're going to click Logical, and we're going to choose If. The function arguments box appears on the screen for the if function. In the logical test box, you've got to put in what we're testing. So we're going to type the expression. This is what we're going to test. L5 is greater than 0. That's the test. L5 is greater than 0. I wonder if I put an I. Let me make sure. L5. Okay, so this is our test. If L5 is greater than 0, okay, we're going to test this. So in number 5, we're going to type a 1. So if it's type 1 in the value, if it's true. So if it's true, we're going to want it to enter 1. And then if it's not true, we're going to want Excel to enter a 0. Click OK. To enter the formula, okay, that equals, okay, 0. So up here at the name box, equal if, parenthesis, if L5 is greater than 0, comma, if it's true, put a 1. Comma means otherwise. If it's not true, if it's false, put a 0. So this is what is in the cell M5. Now the value 0 appears in cell 5, indicating that this call, this first call, was within the 15-second hold time goal. So now we're going to drag the fill handle to copy this or extend the formula through the rest of the call log. I'm going to double click and it will fill. Oh, I've got to put those banded rows in there. And so I'm going to fill with formatting. On page 37, I've done that. Let's see, number 9, scroll to the worksheet, deselect by clicking M5. Businesses often report success in terms of key performance indicator, which is KPI. That's the acronym, KPI, Key Performance Indicator, which measures the achievement of a specific goal. The percentage of customers experiencing long hold times is 1 KPI, is 1 KPI that Kiera uses to measure the success of the call center. A high percentage would indicate that the call center needs to improve its service. So now we're going to sum the number of failed calls. Scroll the worksheet down, and in cell B29, enter the formula equals sum equals sum. Double click here. And we want to sum column M. I'll click M and press enter. Okay, so now B29 displays 441, indicating that 441 customers had hold times longer than 15 seconds. Now we're going to click in cell B30. Oh, I'm there already. And we're going to enter a formula equal B29 divided by B8. And this is to indicate or to calculate the percentage of calls with long hold times dividing the number of failed calls by the total number of calls. All right, so we're calculating the percentage of calls with long hold times. Now we're going to click B30. And then on the Home tab in the number group, Home and the number group, we're going to click the percent style to turn this into percent, from decimal to percent. And it displays the value as a percentage. The cell shows that 86% of the calls failed the 15-second hold time goal. That is not good. So based on your analysis, you know the following information. You know that the call center receives about 50 calls per hour. We now know that the average hold time for each call is around 27 seconds. And 86% of calls are not answered within Kiera's goal of 15-second goal. All right, so conversations last around 6 minutes, but can sometimes take over an hour. The average conversation lasts around 16 minutes. It takes about 14 hours of operator time every hour to handle the call center traffic. Kiera wants to know whether customer support can be improved by increasing the number of available operators. And if so, how many operators are needed to provide effective and efficient service? So we're going to answer these questions next on page 39, formatting input, calculated and output values. It's important in your worksheets to identify which cells contain input values for formulas and functions, which cells contain calculations, and which cells contain primary output values. Formatting cells based on their purpose helps others correctly use and interpret your worksheet. The Cell Styles gallery includes cell styles to format cells containing input, calculation, and output values. Okay, so I'm looking at it right now. Here's input, here's the output, and then we have calculation right here. Okay, I'm going to deselect. We're going to apply cell styles to input, calculated, and output values. So go to the Support Calculator worksheet, which is at the bottom, and then select the range B6 through B9. B6 through B9. We're going to format this range as input cells. On the Home tab in the Styles group, click Cells Styles button. This opens the Cell Styles gallery, and in the Data and Model sections, that's right here, we're going to click the Input Cell Style. The selected cells are formatted with light, it says light blue font on a, yeah, that's right, a light blue font on a light orange background, identifying these cells as containing input values for the support calculator. Now select the non-adjacent range, B10, hold down your control, and select B13 through B15. These cells will contain calculations that will be entered later. So we're going to format the selected cells with the calculation cell style located in the Data and Model section of the Call Styles gallery. So we're going to make this calculations. The cells with calculated values are now formatted with the bold orange font on a light gray background. Next, we're going to select the range B18 through B21. These cells will contain the primary output measures used to predict the efficiency of the call center. So we're going to format the selected range with output cell style. We're going to go back up here and we're going to choose output. The cells with the calculated values are formatted with a bold dark gray font on a light gray background. Now that the different types of cells in the support calculator worksheet are formatted distinctly, it is easier to enter the data about the call center in the correct cells. So in B6, we're going to enter the input value 50 as the anticipated calls per hour to the center. Press enter. In B7, we're going to enter the input 14 as the number of operators available to answer the phone calls. Press enter. In B8, we're going to enter the input value of 15 as our desired hold time in seconds. Press enter. In B9, we're going to enter 16 as the average call duration in minutes. Page 40, number 5. In B10, we're going to enter the formula. It's equal to B9 divided by 60. And then press enter. This calculates the average call duration in hours. The formula returns 0.27 hours. Now let's click in B13. Enter the formula equal B6 times B10. And press enter. This calculates the number of operator hours required each hour to handle the call traffic. The formula returns 13.33 operator hours. Click in B14 and enter the formula equal B13 divided by B7. Press enter. Well, we just calculated the anticipated percentage of operators who will be occupied with calls at any one time. At the current workload, 95.24% of the operators will be occupied. Number 8, in B15, enter the formula equal 1 minus B14. And press enter. This will display the percentage of operators who will be free at any one time. In this case, 4.76% operators will be free. We're going to next determine the optimal number of operators to handle the call volume. To do that analysis, we will use a lookup function. Bottom of page 40, a lookup function retrieves a value matching a specified condition from a table of data. For example, a lookup function can be used to retrieve a tax rate from a tax table for a given annual income, or to retrieve a shipping rate for a specified delivery date. The table storing the data to be retrieved is called your lookup table. The first row or column of the table contains the lookup value. Which are the values that are being looked up? If the lookup values are in the first row, the table is a horizontal lookup table. If the values are in the first column, the table is a vertical lookup table. The remaining rows or columns contain the data values retrieved by the lookup function known as the return values. So it compares what is in the first column, and once it finds the number that it matches, then it's going to retrieve from one of these three columns on the screen. Lookup tables can be constructed for exact match or approximate match lookups. In an exact match lookup, like the one that you see in figure 3-31, the lookup value must exactly match one of the values from the table's first column or the first row for a horizontal lookup table. An approximate match lookup is used when the lookup value falls within a range of values in the first column or row. We're going to work only with exact match lookups in this module. Finding an exact match using the VLOOKUP function, we've got to retrieve a return value from a vertical lookup table, and that is this entire table that you see in columns E through H. We're going to use the VLOOKUP function, and it shows you on page 41 what the VLOOKUP function looks like, where the lookup value is the lookup value to find in the first column of this lookup table. The table array is the reference to the lookup table. You want to enter to go over to this table each time to find the information you are seeking. And then the column index number is the number of the column in the lookup table that contains the return value. Keep in mind that the column index number refers to the number of the column within the lookup table, not the worksheet column. So looking at columns E, F, G, and H, this table is recognized as not E, F, G, and H, but column 1, column 2, column 3, and column 4 of this table. Okay, turn to page 42. The lookup table contains the following columns: operators. It'll have the hold probability, the expected hold in seconds, and the failure rate. So note that the lookup table value starts with 14 operators. Okay, we're looking at the table. We're looking at E6, and it starts with 14 operators. Now, this is due to the mathematics of queuing theory, and so it starts with 14. All right, so we're going to use the VLOOKUP function to determine the hold probability. So click in cell B18, probability of waiting on hold. And on the ribbon, we're going to click Formulas, the Formulas tab. And in the Formula Library, we want to click the Insert function to the far left. Click the Or Select a Category box right here. And then click Lookup and References. Lookup and References in the list of function categories. Scroll down the select a function box, and then we're going to double click VLOOKUP. It's way down, very bottom. Double click VLOOKUP, and this brings up the function arguments box for the VLOOKUP. In the VLOOKUP value box, we're going to type lookup absolute B absolute 7. So we're going to always refer to B7 because we're locking it down. We're anchoring it down. So for the lookup value box, we've typed B7 to reference the number of operators entered in B7. Step 6, in the table array box, so we're going to go down here to the table array, and I'm going to move this over here out of the way. We're going to type E5 through H32. Well, what I'm going to do is select E5. We're telling it to search. Oh, okay, let's see here. Okay, guess we'll type it in. So, absolute E, absolute 5 through absolute H, absolute 32. So you're telling Excel that it absolutely has to always go to E5 through H32, which is the table, to find the results. Number 7, in the column index number box, we're going to type 2. So we're telling Excel to match whatever number, and once it matches the number, go to, this is column 1, go to column 2 and pull the result that matches. All right, so now in the range lookup box, we're going to type false because we want it to be an exact match, so we type false. Okay, now on page 43, it's showing the function arguments dialog box for the VLOOKUP function, and we've typed all this information in, and then we're going to click OK. Okay, so we told it to whatever is in B7, which is 14 operators in B7, always pick this up, go to this table to locate anything that's 14, and then go to column 2 and retrieve that information and shoot it right into this box right here. Okay, now we're going to move on. Based on the result of the VLOOKUP function, 80.32% of the customers will have to wait on hold if only 14 operators are working the call center. Page 44. Use the VLOOKUP function for the other output cells. Click in B19 and then enter equal VLOOKUP VLOOKUP parenthesis absolute B absolute 7 comma absolute E absolute, absolute. So we entered it in the table the first time. Now we're, each of those text boxes in the table are separated by commas if you're going to type it out. So we've got the absolute B, absolute 7, and now we're going to give the table array, which is absolute E, absolute 5 through absolute H, absolute 32, comma. We want it to retrieve whatever is in column 4, so type a 4, comma, and type, choose false. Close the parenthesis. Okay, so now let's check to make sure our VLOOKUP formula function is correct. It should read equal VLOOKUP parenthesis absolute B, absolute 7, comma, absolute E, absolute 5, through absolute H, absolute 32, that's the table array, comma, ooh, I put 4 and it should be 3. So I was looking at the wrong step. So I know that I need to change this from 4 to 3. And then comma, false. We're going to retrieve the value from the third column of the lookup table. All right, so we're going to go ahead and press enter. And so we told it in the, let me click here. So what we said was we want to do a VLOOKUP. And we want you to find the number 14. And the number 14 is in this first column. And once you find the number 14, we want you to, in this table, this is the table array, we want you to go over to column 3 and pull the information. It's got to be exact. 14 needs to be an exact match to 14. And then once you find 14, go over to column 1, 2, 3 and pull the information and put it in to B19. This is going to retrieve the value from the third column. So Excel returns the value of 1,156.63, indicating that the expected hold time is 1,156.63 seconds. Now we're going to click in B20 and we're going to enter the formula equal B19 divided by 60. We're going to convert the expected hold time to minutes. Right now it's seconds. And then press enter. The expected hold time is 19.28 minutes. Now we're going to click in B21 and we're going to enter a formula. And this time I will do the VLOOKUP. Where's the lookup? Right here. So let's click on the book. And this is the third way of learning how to do this. So we're going to go down to VLOOKUP, which brings up the box. And then we want the lookup value to be absolute. So we want to do the dollar sign. Absolute B, absolute 7. So that's what we're wanting to match. And we're going to go to the table array, and we've got to tell it the table array to go to. So it's absolute E, absolute 5 through absolute H, absolute 32. There's 32 rows in the table. Then comma, and once it matches, we want it to go, oh, not comma here, sorry, not comma. We're going to go down to the number, and we're going to enter, once it finds its match, we want it to pull or retrieve the information in column 4 and put it into B21. So column 4, we want it to be an exact match, so false, and then click OK, which it is, 79.49%. 14 operators are barely enough to handle the expected workload, resulting in unacceptable hold times of almost 20 minutes. Increasing the number of operators should improve the situation. Hey, on page 45, we're going to be performing what-if analysis with formulas and functions. A what-if analysis explores the impact that changing input values has on calculated values and output values. There are two examples of, looking in here, there are two examples of the what if analysis. The first one is called using trial and error. The second type is using goal seek. Using goal seek. Okay, so first, using the trial and error. One way to perform a what-if analysis is by trial and error, where you change one or more of the input values to see how they affect other cells in the workbook. Trial and error requires some guesswork. We're going to, on page 45 at the bottom, we're going to investigate call center scenarios using trial and error. In cell B9, let's see, let's see here. Call center scenarios using. In cell B9, enter 11. Okay, I should be probably down here in, I'm wondering if we should be in the staffing. Yes. I don't see where the book told us to go to staffing. Okay, so that's what we're going to be doing. Staffing calculations. Let me write that in my book. Go to staffing calculations. Worksheet. Okay, so in B9, type 11 to change the average call duration from 16 minutes to 11 minutes. Oh, let's look and see what's in B9. I may be wrong. And I am wrong. So this is not where we're entering it. Let me delete it. Let's go to the support calculations, and we're replacing 16 minutes right here with 11. And since we're doing this, it's going to have an effect on all the other numbers. So we changed the average call duration from 16 minutes to 11 minutes with a shorter average call duration. The probability of waiting on hold drops to about, let's look, drops to about 10.06%. Look at B18. B18, 10.06. All right, so it dropped. And the expected hold time drops to 13.74 seconds. Handling calls more efficiently will greatly improve the customer experience with the call center. Okay, so I've erased, I've had to go to the other worksheet, and now I'm staying with support calculation. Okay, now, number 2, in cell B9, all right, so let's restore it. In B9, we're going to replace the 11 with 16. And so as you can see, we're back to 14 operators rather than 10. She believes that the operators cannot successfully wrap up calls faster than the 16-minute average. Now we're going to click in B7, and we're going to enter 18 for our available operators. We're going to replace. Okay, and so we're going to increase the number of operators at the call center. And with the 18 operators and average call durations of 16 minutes, the probability of callers waiting for an operator is 16.57% right here, with an expected hold time of 34.09 seconds. Kiera thinks this might still be too long, but additional operators would improve the situation remarkably. Okay, so number 4, in cell B7. All right, let's go back up here to B7. And instead of 18, we're going to increase the number of operators to 25. Let's see what this does. All right, so it further increases the number of, we've increased the number of operators, and with even more operators, the probability of customers being put on hold drops to a 0.30% with expected hold times of a 0.24 seconds. In other words, with 25 operators, calls to support center will be almost always answered immediately. This is the expected hold time, and it's 0. At some point, increasing the number of operators will no longer be cost effective, as more operators will be idle waiting for the next call. So Kiera believes having 25 operators on call at all hours provides the right balance of customer support and busy operators. Kiera wants to determine how many staff members are needed to ensure that 25 operators are available for every shift. Staff size is affected by what is known in business as shrinkage, in which the number of available employees to perform a task is reduced due to illness or vacations and competing duties like staff meetings. So Kiera created a staffing calculator worksheet to calculate the shrinkage factor for the operator staff and determine the staff size need to compensate for the shrinkage of those that are gone. They're either ill or on vacation or in staff meetings. So on page 47, we're going to calculate the total hours a typical operator works. So we're going to go to the staffing calculator sheet at the bottom, and in cell B9, enter the formula equal B5 times B6 minus B7. Okay, so what we did is we took B5, which is the working weeks, and we multiplied it by the days per week minus holidays per year. Okay, we're calculating the total working days per year less days in which the call center is closed for holidays. The formula, let's see what it returns. The formula returns 253.5, indicating that the call center is open 253.5 days per year. Let's click in B10. Enter the formula that it's equal to B9 times B8. Okay, so we multiplied the number of days in which the call center is open by the number of hours per working day. The formula returned 2,028, indicating that the call center is open 2,028 hours per week. In cell B15, enter the formula equal parenthesis B13 plus B14, close the parenthesis, times B8. This multiplies the number of days allotted for vacation and sick leave by the number of hours per working day. The formula returns 160 hours, indicating that 160 working hours will be lost to vacation and sick leave. Okay, in cell B20, we're going to enter the formula equal B9 times parenthesis B18 plus B19, and then close the parenthesis. We multiplied the number of days in which the center is open by the number of hours spent on breaks and staff meetings. The formula returns 570.375 hours, indicating that 570.375 hours will be lost per year to duties that do not involve answering customer calls. Next, we're going to calculate the shrinkage factor for staffing call center operators. To calculate the shrinkage factor, we're going to click in B23 and enter 25. That's the number of operators Kiara wants available to answer the calls. Now we're going to click on B24 and we're going to enter the formula equal B15 plus B20. We added the total hours lost each year to absences to the total hours lost to daily tasks. The formula returns 730.375 hours, which indicates that 730.375 hours will be lost each year to things not involved with answering customer calls. Okay, let's turn the page to page 48. In cell B25, enter the formula equal B24 divided by B10. Well, we divided the total hours lost by the total hours the call center will be open. The formula returns 36.0%, indicating that 36% of the available hours will not be spent on answering customer calls. Step 4, we're going to click in B26. We're going to enter the formula equal B23 divided by parenthesis 1 minus B25. Close the parenthesis. We calculated the total staff required for shrinkage factor. The formula returns 39.07, indicating that Kiara would need a staff of 39 or 40 employees to cover the call center at the desired level of efficiency. Okay, so although having 39 or 40 operators on staff will allow 25 operators to handle calls at any time, Kiara does not have the budget to hire that many people. The company can afford to hire staff of only 30 operators. So Kiara wants you to determine how many operators would be on call with a staff of 30, assuming the 36 shrinkage factor. So we can answer that question with goal seek. So we have guessed, we did some guesswork using the what if analysis, and we used the trial and error. Now we're going to learn to use goal seek. Bottom of page 48, goal seek reverses the trial and error process by specifying an output value and working backward to find the input value needed to reach that goal. The output is always a calculated value, and the input is always a constant that can be changed using the goal seek tool. Page 49, in this situation, the output value in cell B26, which calculates the total staff size for the given shrinkage factor. So we're going to use the goal seek to set the staff size to 30 employees. That is what Kiara can handle in her budget. So on the ribbon, we're going to click the Data tab at the top on the ribbon, Data. In the Forecast group, in the forecast group. Okay, right here to the right, we're going to click What If Analysis button. So we click on the What If Analysis button, and we're going to click the Goal Seek. Goal Seek. And then we're going to, we clicked on Goal Seek. The Goal Seek dialog box opens up, and then we're going to click in the Set Cell box. So let's click in here. I'm going to double click. And we're going to type B26. B26 to specify the output cell whose value you will set using Goal Seek. And then in the To value, we're going to click, this is our goal right here. We want 30. And then number 5, in the by changing the cell box, B23. That's the number of operators. So we're going to put B23. Okay, so the set cell is B26, which is the operators on staff. And then we're going to set the goal of 30 operators on staff. And we're going to change, we're going to see what our goal is if we hire 30 employees. Okay, so it shows that the target value 30 will give a current value of 30. So it changed it from 39 to 30. Let's see what else here. In the, okay, we did that. We clicked OK. And it shows the value in cell B23. So let's go to B23. This changed. This changed to 19.1956361. These are the operators on call. And the value in cell B26, operators on staff, changes the goal value to 30. So she'll have 30 operators hired on staff, and she'll have 19 operators on call at all times. On page 50, this analysis shows that with a staff of 30, Kiara will have approximately 19 operators available to answer calls at any time. Kiara wants to know whether 19 operators will be enough. So, page 50, we're going to go to the support calculator worksheet. So go to the bottom, go to support calculator. Oh, I've got to click OK to get rid of this box. Support calculator. And then in cell B7, we're going to type 19 to set the number of call center operators. I'm going to press enter, and it's going to make some changes. The results will show 10.33% probability of waiting on a call. The customers will be waiting on hold for, okay, that's the waiting customers. 10.33% will probably hold for around 17.51 seconds. With 30 operators on staff and 19 operators on call at any time, a 17 to 18 second wait is still a bit longer than Kiara's 15-second wait time goal, but given her budget constraints, she has no choice. This is a reasonable compromise for her. This concludes session 2 of Chapter 3, Excel Chapter 3 module, Performing Calculations with Formulas and Functions.